Now let's start with the source transformation. As I told you, source transformation means we can convert the voltage source into current source, or we can convert current source into the voltage source. But it is possible only and only for the independent source. Okay. This case is not possible for the dependent source. Clear? Only for independent voltage source and for independent current source. Now there is one condition that you must remember, that voltage source must be connected in series with the resistance. Okay. No. I'm saying that voltage source must be connected in series with the resistance. That means if suppose the voltage source is connected in parallel with the resistance, then in that case we can't convert the voltage source into current source. So it is a necessary condition that it should be connected in series with the voltage source. Okay. Like suppose if there is a question and they said to they, like you feel like you need to convert it into the current source, so in this case will you be able to convert it? We need the series, so this must you need to remember. Okay. So similarly, in this case, current source must be connected in parallel with the resistance. If they have given current source in series with the resistance, then in that case, you won't be able to convert it. Got it? Now, this condition you must remember. Now see how can we convert as according to this example. If we are having voltage source in series with the resistance, we can convert it into current source. Like see, according to this sign convention, positive above and negative below. So current is moving upward or downward? Upward. So we'll mark the sign as upward only. Okay. If according to the sign convention, if suppose negative here and positive here, then we'll mark the current in the downward direction. Clear? Now suppose here there is 5 ohm. This 5 ohm must be connected in parallel with the resistance. Same amount, same resistance. If there is 5 ohm, then we connect the same amount of resistance as it is with the current source. Okay. Now suppose they have given you the value for voltage is 10 volt and we need to get the value for the current source, right? So current is how much? Can you tell me? I is how much according to Ohm's law? So I would be equal to V over R. V is how much in this circuit? So I would be equal to 2 ampere. It's so easy to convert now. Okay, now I am telling you the vice versa as according to this. They see as according to your PDF, we have applied Ohm's law, right? So V is VT, right? I is how much is the current flowing? IN, and RT is the resistance. Here also RT is there and here also RT is there. So it will be always the same resistance. Clear? Now the next thing, can we convert the current source into the voltage source? Yes. So again the same resistor which is connected in parallel to the current source connected in series with the voltage source. We can convert it like draw it like this also, or we can draw it like this also. Doesn't matter because both are in series, right, with the voltage source. Correct? Now I am taking the same value 2 ampere. This is suppose 2 ampere and here we need to get the value for voltage. So according to Ohm's law, V is equal to I into R. I is how much here? 2. Resistance is how much here? 5. So voltage will be how much? 10 volt. So we got exactly the same circuit which we have studied. Okay, this is what they are saying exactly. So the circuit should be exactly the same. Got it? Now we'll do next we'll do the numericals based on this. Okay. Now this is the source transformation. So in your paper they'll specially mention that you have to do it by source transformation only. Okay. Now see, as you can see that in this case current source is connected in parallel with the resistance, right? So can we convert it into the voltage source, this green portion? Yes, we can convert it. So rest of the diagram is same, right? We didn't touch the diagram, this 20 volt and 5 ohm. It will always be the same. So we can mark it as 20 volt and we can mark it as 5 ohm. Now as you can see that current is moving upward. So we'll mark the voltage a sign according to that current should move upward. Okay. So resistance is how much? 10. So same amount of resistor that must be connected in series, right? That is 10 ohm. Here, okay. Now see, we simplify it, converting this current source into the voltage source. Basically, that green portion is replaced by this green portion, right? Now see, can you tell me any one benefit which see that what we get it after converting from current source to voltage source? But this is one of, but see, tell me the main factor. Original circuit is consist of how many meshes? Original circuit means this one circuit, two meshes. And if we convert it into a voltage source, then it would be converted into how many meshes? So whenever you convert it, it will always reduce one mesh. So your one mesh reduce, one variable will be eliminated and your work will be easy, right? Here you need to solve two equation, but here you need to solve only single equation. Correct? Understood? Now in the same circuit, what we are doing now, we are converting this voltage source into the current source. Okay? Now first of all tell me, can we convert this voltage source into the current source? Yeah, draw the diagram by your own and then tell me how we'll draw it. It will be current source, it should be in upward direction, right? Positive to negative, and the resistance which is in series that must be connected in parallel, same value 5, 10, 1. Now can you tell me what would be the value of I over here for the current source? Four. Okay. Now see, we have converted voltage source into current source. We have increased one mesh or decreased one mesh? Yeah, increase, right? So which one is more beneficial according to you? Converting voltage source into the current source or converting current source into the voltage source? Have only one. Got it? Understood? Okay. Now next of the theorem, as you already studied about the Thevenin theorem, right? And you already studied about the Norton theorem. Now next theorem will have, that is maximum power transfer theorem. Okay? Now, can you tell me, like, suppose, just imagine this is your house and you are using bulb in your house. Okay. So, what do you want? That from the government, maximum power should transfer to the bulb or minimum power should transfer to the bulb? Maximum. So, for that, there is one condition. What was that condition? No, no, no. There is one condition for the maximum power. Okay. By using P is equal to VI, we won't be able to get the maximum power. Okay. That's what I am telling you. That if the load resistance means bulb resistance is equal to the Thevenin resistance. Okay. What is Thevenin resistance? Like suppose here is your MCB. Okay. You know MCB, and between MCB and bulb there are lots and lots of wires, right? And these wires will have resistance also, correct? Remember, all these resistance would be converted into Thevenin resistance. Yes. So what he is saying, that if Thevenin resistance of the wire is equal to the load resistance of the bulb, then only in this condition maximum power will transfer. Got it? Only in this condition maximum power will transfer. If suppose RL is not equal to the RT, then in that case it is not, maximum power will not transfer through the bulb. Got it? Yeah, no, it will not. If power will get it across the bulb, but not the maximum, right? Okay. So according to this one, we'll have, as you know, uh, V P is equal to V into I, right? So for the load means, as I told you, for the load is what? Bulb, है ना? So bulb is denoted by load. So PL must be equal to L into IL. Yes or no? Hmm? So PL is how much? PL is you already calculated. PL is equal to RL divided by RT plus RL into, that you have already studied in Thevenin theorem, right? Similarly, IL is how much? IL is T over RT plus RL. Now, can you multiply these two terms? And now, can you tell me, after multiplication L and IL, what you will get? Will get this value. So you need to remember all three formulas, okay, for the numerical. In this they have done derivation also. Derivation will come in your paper or not? Only the main function, huh? Okay. Now let's do one numerical based on maximum power transfer theorem. Now in this case, this is the set R1, R2 voltage and RL. So RL they didn't give it, right? And they ask you to how much power, maximum power across the load resistance, right? So we'll have one formula for maximum power, that is V square T divided by 4 RT, or we can say V square T divided by 4 RL. So write down these two formulas, that one of the condition for maximum power is this one, and P max is how much? P square by 4 RL or V square by 4 RT. Okay, tell me any doubt? Now can you tell me how can we get the value for RT? So now in this case, voltage source must be short circuit, right? And we need to calculate RL 25. RT is how much in this case? 4 ohm, because they both are connected in parallel, that would be equal to RL. So now we got the value for RT. Yes or no? That's why I make this is a voltage source. I remove the voltage source and place a plain wire across this. Yes or no? No, we never put the plain wire across RL. Whenever we need to calculate IN, wait. You are saying that we need to calculate it by RT by method VOC divided by ISC, right? Okay, if we plane for that ISC, if I'll mark ISC, you can do it by both the method. Answer would be same. First you need to calculate VOC, so positive, negative as it is, and that would be VOC, right? Okay, so 50, 25. Here is plus minus VOC. Now tell me the value for VOC. For where the load resistance was connected, it was always VOC. Now tell me the formula for the voltage division rule then. 5/25 multiplied by 50. That would be 10 volt. Okay. Now calculate ISC. If you remove the voltage, then there will be any source, and if there is no source, then there will be no current flowing. Yes or no? Now calculate ISC. Okay, cancel 5 ohm. ISC is how much? (50/20) 2.5. Okay. Now you need to calculate RT. RT is 10/2.5. That would be 4. Okay. Now maximum power formula is P square over VPOC that we calculated, that is 10 volt. 4. RL is equal to RT now, so it is 4. So 100/16, that would be 6.25 watt. Got it? Next one is the scaling and linear circuit. As you already know, linear elements are those elements which follows Ohm's law, right? That is V is directly proportional to I, and in those elements we mainly use resistor. Correct? So here 20 volt is there. From here we can get V1 and here we can get V2 by using voltage division rule, right? So can you tell me what would be the value for V1 and what would be the value for V2 by using voltage division rule? Hmm? Now it's fine. Okay, now tell me. I was asking V1 for volt. Tell me the value. 2 plus 3 multiplied by 20. So we'll solve it, then we'll get 2 by 5 over 20, 5, 4, and it would be 8 volt. So V1 is how much? 8 volt. Ideally, like you are supplying 20 volt, right? And from this 8 volt is consumed by the resistor R1. So how much is the left voltage for R2? 12 volt? 12 volt now. Let's calculate separately for V2. It should be same. V2 is how much? 3 divided by 5 into 20. Again, it would be 12 volt. This is known as scaling. Okay. So input is 20 volt independent voltage source. Basically, scaling is V1 plus V2 would be equal to, okay, clear? And they are outputs are increased by a factor of 3. Like suppose if instead of 20 volt I gave this voltage as 60 volt, okay, so in input side I multiplied with 3, yes or no? Output also multiplied by 6, so it would be 8 into and 12 into, can calculate it, you will get the same answer. 8 3 is 24, 12 3 is 36. So 36 plus 24 would be 60. That is known as scaling. Understood? If input we multiplied by 3 or 4, then output is also multiplied by the same factor. Okay? Easy? Okay. Now they said superposition and linear circuit. Same thing they have applied like this. Let us consider with of one sample. Like this is the circuit, correct? They ask you to calculate Vt and It by using superposition theorem, right? Vt is how much? That is the voltage across 5 ohm, right? It is how much? The current across 10 ohm, right? And they said that we have to do it by using superposition theorem. Clear? So in the superposition theorem, we'll take one source at a time. Okay. Now can you tell me how many sources are there in this circuit? This question will be solved in steps. If we'll have three sources, then how many steps will be there? Three steps. The first step will take first source, eliminate second, and in the second step we'll take the second source and eliminate first. Clear? First we need to take the first voltage source and then we need to take the second current source. All at a one time only single source will be there. Okay? Like if I and voltage source must be short circuit or open circuit. Voltage source must be short circuit always, whether it would be a Thevenin theorem or a superposition theorem. Okay, and current source would be open circuit. Clear? Voltage source shorted, right? Sorry, in the first step we have to take the first source. We need to take the first source, and current source would be open or not. And in the second step we have to take, tell me which source. In the second step we need to take which source? Current. Voltage source must be short or open. Understood? See, this is the first step they have done. Taken the voltage source, current must be open, right? Now they have calculated what they are asking, VT and IT, right? Now we need to calculate IT. Can you tell me how can we get IT? IT, or we can use I1. You can change the name also. Let us consider this one as I1 for the first step and this one would be V1, right? Now you tell me how can we get I1 and V1. See, for V1 you can apply voltage division rule, and for I1 you can use simply Ohm's law. V by total resistance. Okay, you have taken only 10 ohm, you include 5 ohm also. 10 plus 5. Clear? Now in the next step we need the second step, and in the second step what we need to take the current source. Yeah, the current source. So now we have taken the current source. Okay, like this is 2 ampere plus minus 5 ohm and this is 10 ohm, correct? Now need to calculate I2. This time for the second step I am marking I2 and you need to calculate V, right? Now tell me how can we get V and I2. You can use current division. Tell me the formula. I write it here. Now this is your first step. In the second step you will take current source, right? The voltage source must be short. Yes or no? Now in this it will have VZ2. Now you for VZ you simply need to calculate VZ1 and VZ2 and add it. Simple. Okay. but for VZ we need to calculate the current, right? Obviously. So how many meshes are there in the first circuit? And yeah, yeah. No, no, this one will not count it. Okay, you are correct, it's 2. And how many meshes are there in this? 3. So you need to solve this 2 mesh equation and 3 mesh equation, right? Like suppose this is I1 and I2, but we need to calculate the current in 20 ohm. So let us consider as IZ1. Okay. So can you tell me IZ1 is how much? I1 plus I2, I1 minus I2, or what? IZ1 is IZ1 and I1. They are at the same direction or opposite? And I2 and IZ2. Sorry, IZ1 and I2 will be in same direction or opposite direction. So that will be negative, right? So can we say that IZ1 is equal to I1 minus I2? Yes or no? Tell me the equations. For the first circuit, first step, would be, I'm writing here, minus 10 plus 5I1 plus 20, I1 minus I2 is equal to 0, right? For the second mesh, plus 10 plus 10 I2 plus 10 I2 minus 2ix, eh, sorry, plus 2ix, you are taking first sign, and plus 20 I2 minus I1, right? And Ix is equal to I1. Yes or no? Can you solve these 3 equations? You will get the value for I1 and I2. You will get IZ1, multiplied it with 20 ohm, then you will get VZ1, right? Similarly, you need to do it in this case, 5, 20, 10. Yeah, this is the easiest method. Okay. Again, I3 is how much? Minus 5. And I1 is how much? Minus 5 I1 minus 20, sorry, you are taking the percent, plus 5 I1 plus 20 I1 minus I2 is equal to 0, right? And for the second mesh, plus 10 I2 plus 10 I2 minus I3 plus 20 I2 minus I1, right? And I1 is equal to Ix. Again solve I1, I2, I3, that you will get IZ1, IZ2 multiplied it with 20, then you will get VZ1 and VZ2, and you will get VZ. Okay. So after solving, I am telling you the final answer, that is VZ1. You will get it as 6.875, and VZ2 you will get it as 7.8125. Okay, this is your final answer. Understood?